Well, welcome back to part 10. I think we'll kick this one off. Before this video is over, I plan to change out this capacitor and this capacitor. We're pretty much done with this section over here. But I do have a question I want to ask. Does anybody see anything strange about this chassis? You know, let's take a close-up look. We'll just scan around it. Let's just go ahead and look slow and easy like, just as if it was sitting in front of you at the bench and you're kind of looking it over and everything. What's somewhat unusual? Come on now. You all have sat at benches many times and looked at chassis. What is weird about this one? Well, I'm going to tell you. Where the heck are all the capacitors? Now look, we've got an electrolytic here, an electrolytic here, and I think this one calls for 3 electrolytics right here. Here's the third one, maybe. I don't even know if they're in the right spot. Now down here we have a coupling capacitor that couples the audio output transformer pin 3, which is 1, 2, 3. That's correct. It connects it from pin 3. It's a 0.01 microfarad, by the way, over to pin 2 of the second detector, which is correct. It's hooked to pin 2 down there. And of course we have these 2 capacitors that we're going to change out. We've already seen those in previous videos. So the question is, where the heck are all the rest of it? All the capacitors. Let's take a look at the schematic a minute here. I've taken a green felt tip pen, my little green felt tip right here. And I went around and I highlighted all the capacitors that's supposed to be in this chassis. Now I also highlighted a choke, which I didn't need to do. That does not apply. And I also highlighted this capacitor right here, which is a 0.0005, okay? Now that 0.0005 is actually this capacitor right here, this Aerovox. You'll hear more about Aerovox here in a few minutes. And let's see what else we got here. This capacitor, let me back up. This capacitor here, 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 here. Where the heck are all the capacitors? And it's been bugging me for a while. I was thinking, well, maybe somebody just ripped them all out and never put them back. Well, that didn't make any sense. You know, here's a couple more up here. Here's one right here, and here's one right here. They're not there. They're not in the chassis. And believe me, no one has ripped them out and left them out. Well, I'm going to tell you where they're at. They're inside this box. I now know what's inside this box. Before my electronics mentor, Brendan, became ill, and I haven't heard from him since. God, I wish I could hear from him. I wish somebody would send me an email. I'm so stressed out over this. I'm not the kind of person that gets stressed very easily, but this kind of thing, lack of, you know, there's the old story, you know, no news is good news. In a case like this, that's not true. I really would like to hear from him or someone in his family to tell me how he's doing, what's going on. Maybe he's given him direct instructions not to do it. I don't know. I hate to bother him. I hate to send emails or any of that stuff. You know, if he's having real problems, they got enough to deal with without putting up with me. Anyway, before he got ill and had to have operations and all that stuff, he said that he had worked on a radio similar to this years ago, and he wanted to talk to me about the capacitors underneath the, he said, he didn't say in the box, he said the capacitors underneath the tuner. And he said, when you get to that part, we'll talk about it. Well, we've never got to that part. And I think what he was talking about, now that I put what he said together with this schematic, I think what he was going to tell me was all these capacitors you see here were placed inside that metal box, probably for some sort of, I don't know, maybe some sort of shielding. Maybe they had an, I don't know, seems to me they kind of went overboard, but maybe they thought it all needed to be shielded inside that box. You know, when this is all over, there's a possibility that box can be eliminated and all the capacitors put on terminal strips, that sort of thing. I don't know what I plan to do. If anyone else out there like Dennis Carter or anyone, has had any experience removing all the all the capacitors being in one area and then having removed them. Did he put it? Did the person that had that experience, whoever it is, did you put them back in the box, or did you just kind of lay them out in the chassis like you would normally find them in a later model radio? So I need to know that. So eventually, now this is tar filled. Remember, all the capacitors were stuffed in there. Plus, there's a coil in there too. Let me show you that coil. At least this is the way I figured after tracing. I had to trace out this big old bundle of wires down here where it goes in the bottom down here. See that mess of crap? It goes through a black grommet into that box. After I traced it all out, I came to the conclusion that's where all those capacitors are, to include this 100 microfarad coil right here, which is connected to that arrow box capacitor that I showed you. So that's what we're facing right now. I'll tell you what I'm going to do. I'm going to go ahead and change out these two capacitors, and the next segment you'll see that'll be done. I would like to finish in this segment of the series. I'd like to finish this entire top up here and get this out of our hair. Okay? Hopefully I can get that done. Alright, our two capacitors have been changed. This is the last one. You got them in there now. Now see how it's beginning to, it's beginning to shape up and look a little neater. All I did was remove these two pieces of crap. This is John E. Fast. Oh, that's kind of interesting. Let's see what else it says. John E. Fast and Company, Chicago, USA. How about that? Alright, these are out. And we need to do one more thing. This tab right here is what that, it's the top of that box that had that electrolytic in it. And as I said, it wasn't connected to anything, just hanging out in midair. So I think what I'm going to do is go ahead and snip that baby. I'm going to leave a little bit of length on that thing because we may have to ultimately connect up another electrolytic to take its place. So I don't want to cut it right up close to the terminal. I'll just cut it around in here somewhere in case we have to hook onto it, okay? And that gets rid of that garbage. I don't even know where it went, fell down in there. There it is. Wants to be stubborn. Alright, one more thing out of there that we don't need in there. Alright, she's really beginning to clean up nice now. Let's take a look at one more thing before we move on to something else. This black wire here is just kind of dangling out in midair. And you'll notice that it's connected to pin 4 on the oscillator tube. Pin 1, 2, 3, 4. And it's just hanging out there. And now if we look at pin 4 of the oscillator tube, which is the 27, we see that pin 4 is supposed to be grounded. That's the cathode, okay? Alright, so far so good. So far so good. The problem is, this thing, it's already grounded. See this, you'll remember I told you earlier, once we get a screw through this hole right here, it'll ground that tab right there. And then that tab has a wire that goes over to pin 4, so it'll be grounded when that screw is put in. So what the heck is this? Where did this come from? Well, it's the whole story. They have tapped into it for a ground. It could be the ground for the dial light. I don't know. Not going to worry about it. What I'm going to do is just going to shorten it down a little bit with a little snip of my dikes and just leave it there. So we're going to have a wire hanging off this ground, and up here we've got two wires. One here and one here. Now this is pin 5, this black wire. And this is pin, this is pin 1. Sorry about that, pin 1. This is pin 5. 1, 2, 3, 4, 5. So these are obviously heater wires right there. So we'll leave those where they're at too. Later on, we'll, I'll be looking around probably for these things, and I'll say, oh, well, there's where it was. There's where it went. Okay. Okay, back to the schematic. All right, let's go ahead and color in our capacitors. Notice how all of our orange lines are turning yellow? It's really weird. Okay, we changed that capacitor, and we have changed this capacitor. So now that's taken care of. Now up here, this dotted line for now, again, this entire series, most of the videos I do are for the newbies, the new guys and new ladies into our hobby. This dotted line is the tuner. That's your tuner, your aluminum tuning plates. And this is your trimmer cap. And over here is another dotted line, as you can see. It controls the oscillator tune. This is the oscillator tuner plates. This is the RF tuner plates. And this is, well, they call it the first detector tuner plates. I don't understand that at all, but I don't, you know, Phil over in England, Steel City 321 PB, he contacted me and he says, I'm like you, John. I've been in this business 30-some years, and I don't see what this thing is detecting. I don't either, you know. But anyway, that's the way she is, you know. They call it you got 3 sets of plates, aluminum plates, right here, and right here. That's what the dotted lines go through. See, it goes through here, goes through here, and it goes through this one. This is a trimmer cap. This is a trimmer cap, and this is a trimmer cap. And of course it's connected to ground. The reason it's connected to ground here and over here is because it's bolted to the chassis. The one side of the tuner plates is connected to the frame of the tuner, and the frame is bolted to the chassis. That's why it shows a ground there. So these wires you're looking at right here actually go up through the chassis into the tuner. Okay, right there. And same thing over here. It goes up through the chassis down into the tuner. And down here again, it goes, you see, it would be up through the chassis, no, this way, through the chassis to right here. All right, and then of course your trimmer caps take care of it. Take care of the fine tuning when you tune in a station, move your plates where they're going to be, and then you can adjust your trimmer cap to get your, you know, when you do your alignment, to get everything in alignment there. Okay, so as far as I can tell, we'll go ahead and we'll color the wire here to where it goes up through into the chassis and, you know, to the tuner, because they'll be sticking up above the radio chassis. Let me see if I can find a few for you just to prove it. Well, there we go. Look at all these wires coming up here. Let me back up. That's what these wires are all about, sticking up through the bottom of the chassis. See them coming through there? From underneath, from the coils. These all hook to the tuner. These are these two screws, these two holes here, and I think it's this one right here, all fasten the tuner to the chassis. Okay, it'll be right down there like that. In the last mishmash video, I showed you a cardboard box and what was inside of it, just like you see right here. A piece of gauze wrapped around, you know, an obvious capacitor. We didn't know what kind it was, or I didn't know. But then Dennis Carter left a comment. He said, John, that's an electrolytic capacitor, and he thought it might be C14 in the schematic. And it's probably what it is, even though one end of that capacitor was not connected. So this is an Aerovox electrolytic capacitor. Well, here's a blow up of it. The only difference between the one in this chassis and this particular one in the picture, this one has both tabs at one end, whereas the one in our chassis had one tab at this end and one tab at that end. And you'll see right there, by the way, it says electrolytic section code, so that is an electrolytic. And we have to give Dennis Carter a big old kudo for that. By the way, this one came out of a Zenith 617, model 617 from 1933. Let me show you what that 617 looked like. The 617 from 1933 is the one on the left. Now, boy, I'll tell you what, that is a... Now, if I had a radio like that, I could do another restoration series with no problem. I'll tell you what, any of you guys got one out there you want to donate? I'll even take the one on the right, which is the 619. Boy, that's nice. They were probably both from 1933. Now that's class. That is a classy radio. Let's go down and see if there's any guts on it. There's a little close-up of it. Almost looked like a slot machine, huh? Well, that's a neat radio there. My goodness. There's the chassis. Wow. And looky here. Look what you. Oh my goodness. What we got? We got a cardboard box there and a cardboard box there. A couple of electrolytics, just like we had. I tell you, old Dennis, he's pretty sharp. Not much to the back of the cabinet. The wood sure is nice, though, isn't it? It's not plywood. No plywood or anything there. You know, maybe down here is plywood. Looks like some kind of plywood. I don't know. Dual speakers. By the way, I found that boxed capacitor on I just typed in, as you can see right there, I typed in Aerovox vintage capacitor because I was looking for a different kind of capacitor when I happened to come across this. And this is what came up. And man, oh man, they just gave you all kinds of capacitor examples. Look at this. Hundreds of them. Look at that. It just goes on and on and on, okay? On and on and on. So if you ever need to identify a capacitor, it's an old type and you're not sure, and it might be an Aerovox, just type in vintage Aerovox capacitor. Aerovox. Look at that, it just goes on and on. Man. And there's even more. You can click the bottom down there and give you even more results. Holy mackerel. By now, you folks, even you younger folks, should be, you should be getting the hang on how to, trace out a wire from point A to point B. It's not that difficult. So what we're going to do is finish up this video, and we're going to find this resistor right here. Let me zoom in so you know what we're talking about. We are going to find this 1000 ohm or 1K resistor, and we're going to place it for the one I have in my hot little hands right here. That's what we're going to do. We're going to take this old one out, and we're going to put this one in its place. So let's get started on that. And I'll tell you what, once we're done with that, just about anybody should be able to pick a spot on the rest of this schematic anywhere and trace the wire out to where it needs to go. Now, of course, we're going to go ahead and do it, but your confidence should be increasing just from what we've done already here. By the way, the next section we're going to start on is this top section up here. Not too much over there, okay? And then later on we'll move down to here, and we'll put these resistors on that long terminal strip that I glued to the chassis. And once we do that, we're almost done, for crying out loud. But let's go. Tell you what we'll do. We'll go from ground up through this resistor, down and around, follow the line, truck along, drive, to a coil, one of the coils in the oscillator. Now we have 4 in there. 1, 2, 3, 4. One of the coils in the oscillator. Now it goes through the oscillator and out the other side and back up and around, up to pin 4. To pin 4 on the first detector. Now we went this direction. Well, we could go the other direction. We could start at pin 4, go down, around, same, nothing changes. Down, around, to the oscillator, to a coil in the oscillator coil, through the coil, and across. Follow it up. No difference. Follow it. Through the resistor to ground. Piece of cake. Let's get the old multimeter hooked up. I think what I'm going to do is I'll hook one side of the multimeter to pin 4, and the other one I will hook right there to the top of that resistor. We want to find continuity. Once we get continuity down that line all the way through the coil and up to the top of that resistor, then we'll know we have the right point. And we'll know that we have found our resistor, because there's probably more than one connection coming out of that coil. We got to find the right one. And that's the way we do it. We use our multimeter. Now once we do that, and we think we've got it, then I'll go ahead and measure across that resistor. I'll leave this lead right here in pin 4, and I'll move the other lead to the other side of the resistor, which is ground, and I should get somewhere around 1,000 ohms. Are you feeling me, guys? Are you feeling me? Well, this is our first detector tube, and we've got pin 4. 1, 2, 3, 4. Well, there's a wire coming off it. It runs all the way down, all the way down. I'll bet it runs all the way to the oscillator coil, just like it did last time we looked around. Yes, it does. Right there. See where it's soldered up right there? Let's zoom in a little closer. I want everybody to be able to see this, because this stuff should be getting easier and easier every time we do it. See it right there where it's soldered? Right there in the... right there. Okay? Now, let's go ahead and hook our multimeter up to pin 4 right here. Like so. Let's back up a little bit. We're a little bit too close. Now what we need to do is take the old multimeter and start probing around on the rest of those connectors on that oscillator coil. You'll see down here that I marked that thing with an O. Let me see if I can find it. I got it. Let me tip it back just a little bit. Alright, see the letter O down there? I marked it a while back with the letter O for oscillator. That's why I did it. So when it comes time to be poking around in here, we can find what we want. Here's the wire coming down. Goes into the oscillator coil on that pin right there. And we get all these wires out of the way right there. Zoom in again. Now we need to poke around and see if we can find where that resistor is. Well, guess what? You know, we have a couple of resistors right here. And one of them goes down into the coil back in there on that connector right there. See that wire coming down? Get a little bit closer. See that wire on the one resistor? Comes down, goes down, and it solders to that connector right there. Then we have another one that goes down and solders to a connector right there. That's the wire right there from that one. I'll bet you $1 million that from where I have that thing connected on pin 4 of that tube, I'll bet you it's going to be one of these two. It has to be. I can almost smell it, okay? So I'll tell you what, let's take our little multimeter here. We'll touch this to the first. I'll tell you what, let's do the top one first. It's easiest to get to. Let's see what we get when I touch. Are we ready? Touch. Look at there, look at there. Yes, that's it, that's it. But just to be on the safe side, we're going to go ahead and touch the other one too, just to be sure. You know, don't always, take everything at face value with these old radios. Okay, let's go ahead and touch this one and see what happens. Let me see. Come on, baby. Touch. Nothing. Well, son of a gun. There's our resistor right there. All right, now I told you I was going to touch on one side, which I did. Now I'll tell you what, let me go ahead and touch it again. We touched it on that side. We got about 1.2 ohms. Remember, we're reading through that coil in that oscillator coil. So yeah, it's going to be a 1 or 2 ohm deal. Let's go to the other side. Let's change our scale. We want to measure about 1,000 ohms. Remember now, we're going to go down here and we're going to change it to the 2,000 ohm scale right there, which I have. Now let's test on the other side of that resistor. We should get about 1,000 ohms. If we do, we've found our resistor. 1,357. That's it. But unfortunately, it's about 30% out of tolerance. But I don't care, because it could be right on tolerance, and I would still take that old nasty resistor out and replace it with this really nice one, okay? So let's go ahead and get that thing out of there and put the new one in. Well, there it is. I haven't soldered it in yet, but I will in a little while. I didn't want to disturb, I for sure didn't want to disturb the connection here on that coil terminal right there. I don't want to do that. That's, let me get a little focus here. Maybe I'll help you a little bit. that little coil connection down in there on that terminal on that coil. I didn't want to desolder that and everything and take a chance of messing up that little tiny coil wire that's coming down. You can actually see it right there. So I used the coil method right there, and I used it over here to ground also, which I'll later on go ahead and solder up. And you know, I was going to go ahead and end the video right here, but guess what? Guess what? No. We're going to go ahead. I'm going to give you a bonus. A bonus! Yes, don't you just love it? Now, of course, that'll make the video go a little bit longer. So what else is new, right, guys? All right, what is this? What is this resistor? I mean, if we're going to work on one resistor, why not? You know, why not work on the other? Now, they both come out of that oscillator coil. See that letter O that I put there? They both come out of the oscillator coil. This one here is connected to this terminal right here, and it goes across to ground, just like this one did. Let's find out what that second resistor is. Let's see if we can find it coming out of the oscillator coil. Yeah, this is good. This is good. I'll tell you what, you guys should have this down pat by now. Here's our oscillator coil, okay? This is the resistor over here that we just now replaced. And of course the capacitor, we know where that's at, inside that box. Let's go back to the coils. Where's the second resistor? Right here is where it is. It goes to ground, okay? Now what we have to do is try to figure out if in fact this is that second resistor that I showed you. So how are we going to figure it out? Well, let me see. It seems to me that if we come off of pin 3 and we come around and we go up and we go through half of the coil and we come around and go down through ground. There it is right there. So I should be able to take pin 3 of the 27 oscillator tube. Now keep in mind I'm going to be reading a little bit of coil resistance right here. It'll all add to the overall resistance. We're going to come off pin 3. We're going to pick up a little bit of coil resistance right here. We're going to come up here like this, and we're going to pick up half the coil resistance here. Now this is all inside that big round coil on the top of the chassis, okay? So we're going to have some resistance here, added to some resistance here, and then it's going to come out the center tap. It's going to go down and through this resistance here, which it says 40 M. But actually, that's in the old schematics, they used M because M was the Roman numeral for 1,000, okay? Nowadays, we use K, so that's actually 40,000. So we're going to have, let's read from pin 3 on this tube and then touch our multimeter on this side of the resistor to see if we get any kind of continuity. We'll probably get, I don't know, 2 or 3 ohms maybe from these coils. But let's just see first if it actually goes to this side of that resistor. Let me set that up. Pin 3 coming up. I have connected the negative side of my multimeter to pin 3 of the 27 tube, which is the oscillator tube. 1, 2, 3. All right. Let's take the red lead and touch it to this side over here of the resistor, the opposite side of ground, where it comes out of the coil. Let's touch this right here. I've got my multimeter set up on the 200 ohm scale, which is the lowest scale. There it is. 1.8 ohms. Take it off, touch it again. There it is. That is the resistor. Now we're going to change it's a 40,000 ohm resistor. Remember that? We're going to have to go higher than 20,000. Let's go up to the 200,000 scale. Right there. Now we're going to touch to the other side, and we should have, somewhere around 40,000. Oh my goodness, this thing is up to 51,000. That's pretty far out. That's about 25% out, okay? So this resistor is in fact that resistor right there, okay? And again, this little adjustable resistor is the one down in these holes I showed you earlier. Probably the bottom one down there, I'm not sure which. Doesn't really matter. We'll get to that later. So let me go ahead and change this resistor. Well, there we go, folks, all soldered in. Now we go ahead and take our alcohol and our brush and we clean our joints. Yes, we do. We always clean our joints, okay? Get that old nasty flux off there. Make them look good. Make them look professional, okay? Best we can. My old shaky hands is kind of hard. Last but not least, let's back up here a little bit. We have found this resistor right here. We have installed it. And we have found this wire all the way down here like this, through the coil, back up. And we come over here like so, and from pin 4, all done. Down here in this resistor, we have gone from ground through the resistor, up here, through half of this coil right here, down through this one, up, and over to pin 3. Now wasn't that fun? Yes it was. Well, that's it for now, guys. Until next time, this is John.